Lecture 12 worksheet, question 7. From 1975 through to 2020, the mean annual gain of the Dow Jones Industrial Average was 652. A random sample of 32 years is selected from this population. What is the probability that the mean gain for the sample was between 400 and 700? Interpret the results, and we're given the population standard deviation of 1540. Let's just check one thing first. The average, or your gain of the Dow Jones Industrial Average every year, is not going to be normally distributed. But that's okay, we can still use the central limit theorem because we have a sample size of 32, which is above 30. Several ways to go about this question. We know that the mean is 652. We know the standard deviation for the population is 1540. And we're wondering, for a sample mean of between 400 and 700, we want to know what the probability is. Now, one route we can go down is we can take those 400 and the 700 values, and we can calculate a z-score for them. Z, if you remember, is the mean. So in this case, the x value we're looking for is the sample mean, divided by the normally just standard deviation, but remember in this case standard deviation is population standard deviation divided by the square root of the sample size. So for 400, you have a z-score of 400 minus 652 divided by, and you can work that out yourself, but I will tell you that it's around negative 0.9257. The z-score for 700, same thing, 1540 divided by the square root of 32 gives you a z-score of 0.1763. Now we could take our z-scores, look them up on the standard normal table, and you should get from tables, we should get probabilities of 0.56997. Now, actually, just before we do this, let's draw a quick little sketch. What are we actually talking about? There's our mean of 652, and we're looking for between the values of 400 and 700. So 0.56997 would be everything to the left that I've just shaded here, to the left of 700, I've shaded in orange. And if you subtract everything to the left of the 400, which I'm going to do in pink, you get that bit in green between 400 and 700. So the probability of 700, that's what we looked up. We're using our z-score for 700. We looked it up in the tables. Probability for 400, we get 0.17730, and that gives us a probability of approximately 0.3927. What does that say? Well, essentially it's telling us that about 39% of the samples have a mean between 400 and 700. How about if you didn't want to use the tables and you just wanted to use the calculator and you wanted to do it all in one go? Let's jump over to the calculator and take a look. So we're going to go for second function distribution. It is a normal CDF in this case. The lower limit I'm going to use, if you think about the graph that we had, we're looking for the area between 400 and 700. So the lower area is 400. The upper is 700. And in this case, because we're using actual values as opposed to z-scores, you can't leave the mean and standard deviation as they are. You must put the mean and standard deviation in. The mean here is 652, and the standard deviation is 272.0 Sorry, I should have said 2324. And hopefully, so it's again normal CDF, lower comma, upper comma, mean comma, standard deviation, close parentheses. 0.39266. Is that the same? 0.3927.266 rounds to 0.7. Lovely.